What is network synthetic monitoring? Most monitoring tells you whether a service is up. Network synthetic monitoring tells you what the experience looks like from where your users actually are and where on the network path a problem lives. Network synthetic monitoring is a proactive testing method. Distributed agents run scripted tests, pings, traceroutes, DNS lookups, HTTP requests, and multi-step transactions that simulate user traffic and measure performance, availability, and paths before real users are affected. The network part is the key. Instead of stopping at the application, it extends across the internet and network path between your users and the services they depend on. That matters because so much of modern digital experience rides on networks you don't own: ISPs, cloud backbones, SaaS platforms, and CDNs. Network synthetic monitoring is how you see across them. How does network synthetic monitoring work? There are four moving parts. Agents run the tests. Public agents in internet hubs and cloud regions for outside-in testing, and private agents inside your own data centers, branches, and VPCs for inside-out testing. Scheduling and scripting define what runs and how often, from sub-minute probes to periodic transactions. Data collection records the metrics that matter: round-trip time, jitter, loss, DNS resolution time, TLS handshake time, and per-step timings. And alerting compares results to thresholds and notifies you when something degrades. The results get far more useful when they don't live in isolation, an idea that we'll come back to. What synthetic test types do network teams use? Different layers fail independently, so you use several test types. Ping and trace route tests give you latency, jitter, loss, and hop-by-hop path data. DNS tests validate resolution behavior and timing. HTTP and API tests measure status codes and response timing. Page load tests use a headless browser for end-to-end web performance. Transaction tests script multi-step user journeys like login, search, and purchase. And BGP monitoring tests track route announcements and reachability, tying the control plane to everything else. Together, these let you isolate which layer degraded: DNS, TLS, the app, or the path itself. How is this different from web synthetic monitoring? Web and application synthetic monitoring, think tools built around browser checks, Selenium, or Playwright, is optimized for the front end, page load, core web vitals, and scripted journeys against your own web properties. This type of testing answers, is my application fast and functional? Network synthetic monitoring answers a broader question. Is the network and internet path between users and the service healthy? And if not, where? It leans on internet layer tests, traceroute, DNS, BGP, and measures from many vantage points, so it can tell an application problem apart from an ISP problem or a routing change. Most mature teams run both types of synthetic monitoring. How does network path analysis fit in? A failed test is only actionable if you can see the path it took. That's why synthetic monitoring and network path analysis go together. The test tells you an experience degraded. The path shows the route, the hops, and the AS level transitions where it happened. By pairing traceroute-based tests with AS path visibility, you can see which routing decisions correlate with better or worse performance. That's the difference between Salesforce is slow and Salesforce is slow for users routed through one ISP because of a transit path change at a specific autonomous system. How do you correlate synthetic tests with real traffic and routing? Here's where this combination pays off. When a synthetic test degrades, real flow data tells you whether real users are affected and how many. And BGP data tells you whether a routing change explains it. That's the difference between an outside-in probe and modern network intelligence. In Kentik, synthetic results, flow telemetry, and BGP announcements sit on the same timeline. And Kentik AI Advisor can investigate a degradation across all of them. Autonomous, flow-based tests even generate synthetic tests for the destinations your real traffic actually reaches, so your testing follows your users instead of just a static list. What are the best network synthetic monitoring tools? Synthetic monitoring tools span several different categories, and the best one depends on whether your main concern is the front-end application or the network and internet path between users and services. For the network and internet path itself, the best tools fall into the network intelligence and internet performance monitoring categories. Kentik is the network intelligence solution for teams that need tests correlated with their own traffic and routing. Cisco Thousand Eyes and Catchpoint, now part of Logic Monitor, are the established internet performance monitoring platforms. Cloud-native options like Amazon CloudWatch Synthetics and CloudWatch Network Monitor fit teams that have standardized on one cloud. Full-stack observability suites, including Datadog, Dynatrace, and New Relic, bundles synthetic testing with APM features. And web or open source tools like Pingdom, Checkly, Grafana K6, and Playwright cover front-end developer testing. If your goal is proving whether the network or internet path is the cause, and correlating that with your own traffic and routing, Kentik is the network intelligence option in this landscape. If your goal is primarily front-end web performance or endpoint experience, a web synthetic or DEM tool is the better primary fit, often alongside a solution like Kentik for the network layer. The short version, if the question is whether the network or internet path is the cause, and you want that tied to your own traffic, that's the network intelligence category. If it's primarily front-end web performance, a web synthetic or DEM tool is the better primary fit, often alongside a network tool for the path. There are 5 main things to look for in network synthetic monitoring tools. 1. Look for global agents where your users are, plus private agents for inside-out testing. 2. The full range of network test types: ping, traceroute, DNS, HTTP and API, page load, transaction, and BGP. 3. AS path visibility, so failed tests are actionable. 4. Correlation with flow and BGP, so you can tie a test to real traffic and a specific route. And 5. AI-assisted investigations to get from alert to root cause faster. The best network synthetic monitoring solution isn't a standalone probe network. It's testing tied to the rest of your network telemetry. You'll find links to our deep dives on synthetic monitoring, network path analysis, and digital experience monitoring in the description, along with a Kentik demo. If you found this useful, like and subscribe for more network intelligence content.